Alright guys, welcome back. Today we are going to look at your quotient rule. Please do not forget to like and subscribe to our YouTube channel. So we are going to look at quotient rule. In our last video we talked about the product rule when we said two functions have to multiply for you to use your product rule. So for quotient, once you hear quotient, just what registers on your mind is division must come into place. So whenever you have y equals to u over v, where u is a function of x and b is a function of x, I won't go through the process of showing you how it was gotten. You can get it directly from your logarithmic rule, or you can get it from your product rule. So our dy over dx is actually v, the denominator, times du over dx, then minus u times dv over dx, then everything all over b squared. So anytime you have something like this, your dy dx should be the denominator times the differential of the numerator minus the numerator times the differential of the denominator all over the square of the denominator. So that's for your dy over dx. So let's quickly solve some questions. Now if y is exponential x all over sine x, what will be your dy over dx? As easy as ABC. Your y prime is take the denominators, which is sine x, dot differentiate the numerator, which is exponential x, then minus take the numerator, which is exponential x, then differentiate the denominator, which is sine x. When you differentiate sine x, you are going to have cos x. Then everything all over the square of the denominator. So you are going to have sine square x. Now there is sine x here, and there's exponential x here, and there's also exponential x here. So I can bring it out. So I'm going to have exponential x, open brackets, this sine x minus cos x. So this becomes your dy dx. So what if we have something like y equals to 3x cubed plus 4 all over 3x raised to the power 4 plus 5x, and you are asked to find dy dx? Easy. Now your dy dx is take the numerator, which is your v, take the denominator, which is your v, this is it, then differentiate the top. Then differentiate the top, which is this. So when you differentiate this top, you are going to have 3 times 3 is 9. So you have 9x plus 0. Then minus, take the numerator now and differentiate the denominator. So you have this. When I differentiate the denominator, 4 times 3 is 12. So I will have 12x cubed plus 5. Then everything all over the square of the denominator. So I'll have 3x raised to the power 4 plus 5x raised to the power 2. So you can leave your answer like this, or you can decide to open the bracket here and also open the bracket here, whichever way. It depends on the option you have in your exam. So they can as well leave it like this. They can go further, but it's making more sense this way. It's somewhat simple this way, so that you not have several x and y's everywhere. So that's for this. What if you have y equals to sine x all over cos x? Okay, now we said whenever you differentiate tan x, you will get sec square x. Remember from your trigonometry that sine x over cos x is tan x. And we told you that anytime you differentiate tan x, you get sec square x. Actually, this is where the proof come into place. We are going to prove that with our quotient rule. Now, whenever you have this, your y prime becomes, take the denominator cos x, differentiate the numerator. Now, when you differentiate cos x, you are going to have, when you differentiate sin x, you are going to have cos x. Then minus, take the numerator, which is sin x, then differentiate the denominator, which is cos x. Cos x, differentiate this, you're going to have minus sine x. Now you see that minus that you had, that minus times this minus will eventually give you a plus. So you have sine x again. Then everything all over the square of the denominator. So you have cos square x. So this cos x times cos x can be written as cos square x. So instead of me to write cos x times cos x, I can write it as cos square x. And instead of me to write this as sin x times sin x, I can write it as sin square x. Now remember from trigonometry that cos square x plus sin square x is always 1. That cos square x plus sin square x is always 1. So I will change everything at the numerator and change it to y. Y prime is 1 over cos square x. Now what is the inverse of cos? The inverse of cos is actually your sec. So 1 over cos square x is equivalent to sec square x. This is why when you differentiate your tan x, you are going to have sec square x. It was gotten from your quotient rule. What about your tan x, your cot x? If you differentiate cot x, you are going to have minus sec square x. So you can go through all these processes to differentiate your cot x. Now, what if this function has a power here, or what if this function has another power here, such that you are going to have both your chain rule and your quotient rule? So let's quickly give an example of that kind of scenario. Let's say you have y equals to 3x squared plus 1 all over x cubed plus 4. Then this one has, let me say, a power 2, or let me use 3. So the first thing, using your quotient rule, the first thing is to take the denominator. So your y prime becomes, take the denominator, you will have x cubed plus 4 raised to power 3. Then differentiate the numerator. When you differentiate this, you are going to have 3 times this, you have 6x. Then minus, take the numerator plus 1. Then differentiate the denominator. Now there's a power in this denominator. So how do you differentiate that? You use your chain rule, which means that this power must come down first. Then you subtract 1 from that power. So this becomes 2. 3 minus 1 is 2. Then you now differentiate whatever is inside. So when you differentiate x cubed, you have 3x squared. So you have 3x squared plus 0, because differentiation of a constant is a constant. Then everything all over the square of the denominator. So you have this is the denominator, then you square it. So let's just simplify further. So let me write this 6x first. So my y prime becomes 6x bracket x cubed plus 4 all cubed. Then minus, I want to write this 3 and this together first. 3 times 3 is 9. So we are going to have 9x squared first. 9x squared. Then before we can write this stuff out. So we have 3x squared plus 1 and x cubed plus 4 all squared. Then everything all over the square of the denominator. So if I open this bracket back, from your rule of indices, this 2 will multiply this 3. So we are going to have this raised to power 6. So we are left with x cubed plus 4 raised to power 6. So that's basically all you need to know for quotient rule. And whenever you have a function all over another function, the best way is to use your quotient rule, which says that the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator square. So that's all for this video. Please do not forget to like and subscribe to our YouTube channel. Thanks for watching. State any issues you have with this course and we'll do a video for you. If there's any question you would like or questions you have, you can just state it in the comment section and we'll do a video for you. Thanks for watching.